Hi everyone, so I'm solving the M25 past paper today, and this is the IB Chemistry M25 SL paper. So we are going to start off with the first question. The first question in section A, because this is the Chemistry SL Paper 1A from May 2025 exams. So this would be perfect if you are studying for your November exams or if you have just started your year 2 of IB, because then you could actually use this to revise any of the topics you've already covered in class. So we're going to start off by going through question 1. Please let me know if you can't hear me, by the way. Hopefully the mic is picking me up well, but just let me know. Okay. So for question 1, it says, a test tube contains a mixture of liquid hydrocarbons. Okay, what is the type of the mixture and the best method of separation? So there's two questions here. Number 1 is asking for the type of the mixture, and number 2 is the best method of the separation. Now this is a multiple choice question, so you have to pick the correct one to answer. But let's look at first of all what it is. So it's a test tube and it has liquid hydrocarbons. Does anyone know the difference between homogeneous and heterogeneous mixtures? So we have an A in the chat. So homogeneous and heterogeneous, it all depends on the state. So if we're asking ourselves if a mixture is homogeneous or heterogeneous, it depends on the state. So a homogeneous mixture is the same state. For example, what that means is like two gases, two liquids, two solids, that would be homogeneous. And in this case, because this hydrocarbon, we have a mixture of two liquid hydrocarbons, that means it must be a homogeneous mixture. So we can immediately cross out C and D because those are heterogeneous mixtures. Then if we move on to the next part, which is the method of separation, here they're describing two things. Number 1, distillation and filtration. Does anyone know the difference between distillation and filtration? That's okay if not. So in terms of the distillation versus filtration, we're looking at first of all, a process by which you are separating things of the same state. So once we are separating chemical, exactly. So it depends on if you're separating liquids and solids or just liquids. So if you're separating chemical structures within the same state, that would need distillation, because distillation is a process by which basically you use temperature and you use that temperature to be able to separate things. So for example, you know that the boiling point of water is 100 degrees Celsius. You also know the boiling point of ethanol is like 50 degrees Celsius. You can use distillation to boil off the ethanol and separate it from the water because they have different boiling points. So that's distillation. And that's what you would use if you have two liquids. Now, filtration is if you have one solid or you have a solid and liquid mixture. Why? For things that would be separated by filtration would be something like a mixture of sand and water, because you can use a filter, kind of like a filter paper, and that will like drip the water through and keep the sand within that. So that separates the sand and the water, and that separates a liquid and a solid. So here, because we have a homogeneous mixture, which is two liquid hydrocarbons, and we have, because we have that, we'd need to use a distillation process to be able to separate them. That's why the answer here is A. So correct for you guys that got it. Moving on to the next question. Next question says, which property is the same for water containing tritium and water containing hydrogen? Anyone have any guesses for what the answer could be? Okay, I'll give you guys a hint. It's not A. Okay, we've got a C. Okay, so we have water that contains hydrogen and water that contains H3. So what does that mean? It means that you have a test tube, for example, or you have some sort of container that has a bunch of water molecules, and we all know that water is like H2O, H2O, H2O. But that water also has on top of it another molecule. Now, some of that molecule is either H plus, or sorry, just hydrogen, and some of that water is going to be H3. So it's asking for the difference between those two molecules, between those two different types of mixture. So water that has H3 embedded and water that has H just embedded. And you guys correctly identified that the answer is B. So the dipole moment of the molecule of H plus is going to be different to the dipole moment with H3. Or sorry, H1 versus the dipole moment of H3. Hold on, my pen just lagged. Let me just connect it really quickly. Okay. Perfect, it's working again. The reason why it's not density is because both of these mixtures will have basically the same density. We'll have different densities. Why? Because here we have an isotope of H3, and here we have another isotope. So the hydrogen within the H2O here is either having one proton and one neutron, or multiple neutrons. Now, when you have multiple neutrons of the hydrogen, that changes the molecule, the heaviness of the molecule, and because it changes the heaviness of the molecule, or the density of the molecule, it therefore changes the boiling point. Because the heavier the molecule is, the greater the density, the more it's going to need more energy in order to boil, right? Because if it's heavier, you're going to have more energy to be able to move it. So the density is higher in the H3 molecule, therefore the boiling point is also higher in the H3 molecule. Now the question is asking us, what is the same? The same would be the dipole moment, because the amount of, I don't know if you guys have you guys heard of the word dipole moment before? But basically dipole moment is the way that the charge is arranged within the molecule. That has nothing to do with the amount of neutrons. Here we're looking at hydrogen molecules with different numbers of neutrons. Different numbers of neutrons in terms of isotopes always changes the physical properties. What are the physical properties? Always boiling point and density and the actual mass. So the relative molecular mass will be changed, because the heavier hydrogen, H3, is going to be heavier, whereas H1 is going to be lighter. The boiling point is going to be changed. The heavier one is going to need more energy to move. The density is going to be changed because you have one with greater isotopes, therefore it's heavier, and one with lower isotopes, therefore it's lighter. Okay? Therefore the dipole moment is the only thing that doesn't change, because the actual charge in the molecule, even if the hydrogen is only with one neutron versus two other neutrons, that will mean that hydrogen still has the H plus charge either way, whether it's H1 or H3, still has the same charge. Someone said I'm triggered. Honestly, mood. Okay, next question. The emission spectrum of hydrogen provides evidence for which feature of the atomic structure? So emission spectrum of hydrogen provides evidence for which feature of atomic structure? Someone has a whole engineering degree and this is just triggering. Makes sense. Okay, we have a B. Any more takers? Yeah, we have another B for energy levels. Yep. Okay, yep, absolutely. Most of you guys are getting that correct, so the answer is B. So let's talk about why the answer is B. Basically, the hydrogen emission spectrum releases specific wavelengths of light depending on the electrons and how they jump between different orbitals within the hydrogen spectrum, between the hydrogen atoms. So we have one here, and one here, for example. So if this is my nucleus of my hydrogen atom, and this little circle here is my electron, that electron can jump up. Either it's from n equals 1 level to n equals 2, and it can jump up to n equals 3, it can jump up to n equals 4, it can jump up to all of those. But basically, the fact that it jumps up means that it also must come down at some point. So once it comes down, it releases a specific photon of light, and that specific photon of light corresponds to the distance between these discrete energy levels. So because that photon of light corresponds to the difference between those energy levels, that basically provides a proof for the fact that different discrete energy levels do exist. Now, why is it not the other answers? It's definitely not the nucleus. Being able to release wavelengths of light doesn't actually prove that there's a nucleus. It just shows the electrons being able to jump up and down. So it's not a nucleus. It's also not isotopes, because to be able to provide evidence for isotopes, I don't know if you guys remember that technique, but that technique is really done with a mass spectrometer. It's not done with the hydrogen emission spectrum. So that's what proves isotopes. Protons, similar to the nucleus, that is really the mass of the molecule. It wouldn't be proved with the hydrogen emission spectrum, because that gives you an indication of how the electron is jumping between energy levels. And honestly, if you guys have been studying for your exams or like paying attention in class, you would have seen the hydrogen emission spectrum being mentioned with one thing only out of this list, and it's either electrons or energy levels. So just by, fact of, you reviewing it, you're going to be able to know that it's energy levels. So pretty simple question. I'd be pretty happy if I got this question in my paper. Okay, next question. What is the maximum number of electrons that can occupy the n equals 3 main energy level? So people here have put C. So the formula for this is 2 to the power, so 2 to the power of the energy levels. Okay? So that means it is 2 to the power of 3. All right? So that will be 2 times 2 times 2. So that will equal to 4 times 2, which is equal to 8, which is what you guys correctly identified as the correct answer. So whenever you see a question like this, think back to this formula, 2 to the power of n, and n is the number of energy levels that you need for the question. Okay, so this is SL, this is standard level. Okay, what is the empirical formula of a compound with the following composition by mass? Someone graduated. Okay, so for these kinds of questions, I really recommend you guys use this specific way of solving it. So here they give you that 50% of the sample is oxygen, 12.5% of the sample is hydrogen, and 37.5% of the sample is carbon. Does anyone know how to answer this question? Okay, so let's go through it step by step. So what we're going to do is we are going to basically imagine that we have 100 gram of a sample of this compound, this mystery compound. And if we were to have 100 gram of this mystery compound, what are we going to have? Well, we're going to have 37.5 grams of this mystery compound is going to be C, right? We're going to have 12.5 grams is going to be hydrogen. And then we're going to have 50 grams, which is going to be the oxygen. Okay? So we're going through 100 grams. We're going to imagine that we have a 100 gram sample. And if 37.5% of a 100 gram sample is, if we convert that to grams, that's going to be 37.5 grams. And then here we have 12.5 grams. And then here we have 50 grams. So what we're going to be looking at here is how we can convert grams then to find the number of moles. Okay? So we're going to do 37.5 divided by, what do we do to find the number of moles? So people are putting C as the correct answer. Okay, yeah, exactly, atomic mass. So we'll see if C is correct. So we're going to divide by the atomic mass, which is 12. Exactly, because we know that the MR of carbon is going to be 12. We look that up in the periodic table. So does anyone have a calculator that can find this number for me? And same, we're going to find the moles of hydrogen. We're also going to find the moles of oxygen. So we're going to divide by the atomic mass of oxygen, which is 16. So this would be 3. I'm guessing someone's done this on a calculator. I don't have a calculator, so I'm trusting you guys to do it. 3, absolutely. This will be 12.5. Okay, so it's actually 3.125. Fine. 12.5. And then we have 50 divided by 16. And what would that equal? So all I've done here is taken the grams and divided those grams by the relative formula mass. Okay, so is that 3.125? So just to double check, 37.5 divided by 12 is 3.125. Is that correct? Okay, so both of them are 3.125. Perfect. So in that case, what we do next is to find the ratios of these to each other, we have to divide by the smallest number, which in this case is going to be 3.1.25 because that is the smallest number we see. So we're going to divide by 3.1.25. We're going to divide by 3.125. We're going to divide by 3.125 to find out the ratio of them to each other. So we're going to divide, and that will be equal to 1. This is going to be equal to 4, and this is going to be equal to 1. 1, 4, 1. So the correct answer is CH4O. So that's how you would solve a question like this, is you want to imagine that you have a 100-gram sample, and therefore find out how many grams would exist of each element, then divide by the molar mass to find the number of moles, then find them in the simplest ratio to each other. So this method is going to work for every single question like this, whether that is going to be a paper 1 question or a paper 2 question. Okay? So it's not always 100, it is always 100 grams because if you add up 50 plus 12.5 plus 37.5, that's always going to add up to 100. That's why I say assume you have a 100-gram sample. So if you add those percentages up, it's always going to be 100. Does that make sense? Oh my god. Someone just finished their MCAT and it has lots of these types of questions. So yeah, I'm glad you figured out how to solve it now. Anyways, so then we're going to do that. Next question. What is the charge of the monoatomic ion usually formed by the element with the following electronic configuration? What is the charge of the monoatomic ion usually formed? So what does this question even mean? Monoatomic ion, usually formed by the element with the following electronic configuration. What do we think the answer is? Okay. So what is this element, by the way, guys? Can anyone look at the periodic table and figure out which element this is? What is this element? Helium, so the electronic configuration of helium, plus 2 electrons, plus another 3 electrons, so with 5. So it's helium plus 2 in the s orbital, plus 3 in the p orbitals. Let me see if I have a periodic table on hand. I actually might do. Oh, I do. Okay, great. So I'm going to make this periodic table very large here. So to find out which element we're talking about here is we're looking at the electronic configuration of helium, which is right here. And helium, we can find it where? We can find helium just here. And it says on top of helium, we also have 2s2. So we also have these 2 here, plus 2p3, which means 3 more. So this is actually, the element we're looking at is nitrogen. That's the element we're finding on the periodic table. And so therefore, if that is the case, what are we going to do? We're going to find the monoatomic ion was the charge on nitrogen that's usually formed with this element. So what charge does nitrogen tend to form? So nitrogen tends to form, if we draw out nitrogen, we know that nitrogen has, it looks like this. So we have the nucleus in the middle, and we know that we have 2 electrons here, because we know that hydrogen has 7 total electrons, right? So 2 in the inner shell. Yeah, so 1, 2, and then 3, 4, 5, 6, and 7. Now, does anyone know the charge that nitrogen typically forms? So people are saying that it's 5, and some people are saying that it's A, which is 3 minus. And in fact, it's actually 3 minus. Now, why is it 3 minus? It's because nitrogen is one of those tricky exceptions that actually forms like these bonds in the way that it would form, for example, like, let me just make this a bit thicker so you guys can see it better. But nitrogen, because it has 5 valence electrons, like this, 1, 2, 3, 4, and 5, it typically forms N3 minus, and actually you can see this because it forms NH3 as a neutral compound. So the hydrogen will combine here, here, and here, and here, like so. And that's your NH3, right? So nitrogen in and of itself actually forms N3 minus, because when it forms, for example, ammonium, which is NH4 plus, that hydrogen comes and sits just on top and forms what we call a dative covalent bond. And that dative covalent bond is not through the donation of any electrons from the hydrogen. The hydrogen actually just comes and sits and takes 2 electrons from the nitrogen. Someone asked, could I still follow this even though I do A-level? Yes, the content is the same, chemistry is the same, and it hasn't changed since. But yes, so here we have NH3, and that's why nitrogen actually forms 3 minus. It doesn't form 5. And this is a really, really good exception to keep in mind and to know what compounds form dative covalent bonds. And actually in our crash course, we have a document that basically outlines, if you are a crash course student, you can see this document, it outlines all the dative covalent bonds. And even if you don't have access to that document because you're not a crash course student, just look it up online, like all the common dative covalent bonds, ask ChatGPT, do something, and find all the dative covalent bonds that come up in your chemistry exam. And that way, like, you guys can study all of them and know them. So if you get a question like this, you know that nitrogen is 3 minus and it's not 5 plus, for example, where it loses all of that. Okay? So there we go. So I'm just going to erase this now. We're going to move on to the next question. So let's take this down. Okay. The next one, it says, which molecule is polar? So for this question, we're going to have to solve and figure out which molecule is polar. I'm going to give you guys so someone's already said A and B are nonpolar, CO2 is linear, it's nonpolar, SO2 is bent, so it has a dipole. Answer is C. Great, so that's great reasoning. I'm going to go through it step by step for anyone who isn't able to follow through with that. So what is polarity? Polarity, by definition, it means that you have 2 things, always 2 conditions that you have to fill for polarity. Number 1, the molecule has to have unequal charges within the bonds. And so what does that mean? It means that, unequal charges within the bonds, aka the bonds themselves have to be polar. Okay, the molecule must have polar bonds to be considered polar. The next requirement the molecule has to have is the molecule has to be asymmetrical, or the polar bonds have to be asymmetrical, or those polar bonds cannot cancel each other out. Okay, so there has to be an overall dipole, aka basically the charges cannot cancel each other out. So those are the 2 the 2 checklists that we have to meet in order to consider a molecule polar. So number 1, we must have polar bonds. And number 2, the charges cannot cancel each other out. So there should be an overall dipole moment. So let's look at A, for example. A is CH4. Now, how do we know if A has polar bonds? Well, in this case, you guys have to go into your data booklet and find the electronegativity values of carbon and hydrogen. To find out if a molecule is polar or not, or if a bond specifically is polar or not, you have to see if the difference in the molecules' charges is a difference of 0.4 or greater. So between 0.4 and 1.7, difference in electronegativity, that molecule or that bond is going to have a polar charge. So what is the electronegativity of carbon? Does anyone have their data booklet? Could they bring up the electronegativity of carbon and the electronegativity of hydrogen? So someone said 2.1. Is that the electronegativity of carbon? I'm going to assume it is so. So carbon electronegativity is 2.1. Okay. Hydrogen electronegativity is what? Okay, so is that 0.4? Or is the difference 0.4? Okay, hydrogen electronegativity is... Okay, so there's so many different answers. I actually don't know which one is correct. If anyone has electronegativity table, please let me know. I currently don't have one at the moment, but I guess I could look it up on Google. So let's see. Anyone know the electronegativity difference between carbon and hydrogen? Yep, exactly. Someone's put, yep, that's correct. Anyways, it doesn't really matter to solve this question, but basically that's what you have to do is find the electronegativity in your table, in your data booklet. So basically what's the answer you're going to find is that the difference, if you subtract the 2.1 minus the 0.4, you're going to have a value that is up to 1.7, between 0.4 and 1.7. So by definition, this is indeed a polar bond between the carbon and the hydrogen. Okay, that's true. So that first condition is met. Now what about the second condition, which is the charges cannot cancel each other out? So if the molecule has a polar charge where the charges are canceling each other out, and the way that I like to visualize this is I like to look at the carbon to hydrogen bond. We know that carbon is more electronegative, aka it likes to take more of the electrons and likes to steal them from hydrogen. We know that that's the case. So because the carbon is more electronegative, it has electronegativity of 2.1 versus the hydrogen, which is 0.4. That means that the electrons are more towards the carbon. So the electrons in the bond are not shared equally. They're actually more towards the carbon than they are closer to the hydrogen. So the electrons in this bond that are covalent bond that's being shared actually exist like this. They're closer to the carbon. So actually that creates an partial negative charge on my carbon, and a partial positive charge on my hydrogen. So that's what that does. So what I mean by the molecule being symmetrical is that there has to be overall partial negatives and partial positives that give me an overall dipole. So what does that mean? So if the carbon has a partial negativity and the hydrogen has a partial positivity, I can say the same for all the other carbons and hydrogens. So this is partial negativity, partial positivity, partial negativity again, partial positivity, and partial positivity here as well. And so we can draw this dipole moments using the specific arrow that looks like this. So plus the arrow going to the negative. So all the charges are going to the carbon, exactly like someone said. There we go. There we go. Now, if these arrows that you're drawing are meeting head to head, that means they cancel each other out. If they're tail to tail or head to head, I would say they cancel each other out. So these two that are opposite each other, here and here, they cancel each other out. And this also cancel each other out. So this is not a polar molecule because you don't have an overall dipole moment because the charges do cancel each other out. So this molecule is not polar. What about the second one? So C6H6. So that C6H6 is actually in a ring, like so. And so that also, the hexane is not polar. And again, those charges are going to cancel each other out. Now, what about SiO2? So for sulfur O2, so like this, sulfur oxide, the molecule, someone said the shape is bent, which is correct. But let's just see the differences in electronegativity. So first of all, how many valence electrons does the sulfur has? The sulfur has 2 here and 2 here. So those are the valence electrons of sulfur. I believe so from the periodic table. Again, correct me if I'm wrong. Maybe I think it has 4 valence electrons, just like carbon. And then what we want to do is we want to put our oxygens in. Now the oxygen is going to show that it will form, the 2 valence electrons are going to form a double bond with sulfur. Yep, exactly, 2 minus, perfect. And so that's how that looks like. Now let's look at the bonds individually. So the bond between sulfur and oxygen, first of all, is there a polar bond? So that's the first question we have to ask ourselves. Is there a polar bond here? And so to be able to do that, we have to go to the electronegativity tables in the periodic table. And exactly, so there is a polar bond, absolutely. So is there a polar bond? Yes. Now, do these polar bonds cancel each other out? Yes, exactly. There is a lone pair here. You're absolutely right. And do these cancel each other out? So we know that sulfur dioxide is a bent structure. Okay? Yes, so O is the, delta minus, exactly, delta negative, and the sulfur is delta positive because the oxygen is more electronegative. So let's draw our arrows. Our arrows are facing like this and like this. But hold on, we know that the sulfur oxide molecule is bent because there's a lone pair here. We know that from VSEPR theory. The lone pair takes up space. Okay? And so we know that this double bond looks like this. We know that these are going to look like this. So are they meeting head to head and tail to tail? Not quite. They're actually both facing downwards. And because they are both facing downwards, the charges are not canceling each other out, so both of my conditions for polarity are met. So in order to answer these questions, you have to keep in mind that any molecule that's going to be tetrahedral like this for example, is going to cancel each other out regardless if the bonds are polar or not. So that's always going to be nonpolar. This is a ring, so it's not likely to be polar. And this is in fact the polar molecule. So those of you who said C, you're absolutely correct. Okay? And then here we have CO2, which I can show you why that is nonpolar. So carbon here has 4 valence electrons. And oxygen has 6 valence electrons, so it forms 2 minus. So it's actually going to form a double bond here and a double bond there. Sorry, guys. Like so. So a double bond and a double bond. So therefore it's going to look like this. But carbon dioxide is a linear molecule. It's not a bent molecule. That's why when we draw our dipoles, which are going to look like this, going towards the oxygen, because the oxygen is more negative than the carbon, and they're meeting tail to tail, that means that they cancel each other out. Remember, head to head or tail to tail, they're going to cancel each other out. Okay? Someone said, when should you start studying for the IB? So you should start studying, I would say, like all the way throughout classes, and make sure that you're not missing classes, and also if you are missing classes, just to catch up on the material. So I would say, like, just do the homework that your teacher assigns, and then start properly studying for your exams, maybe like 2 or 3 months before, after you've submitted all of your extended essay, IAs, etc. But definitely don't leave it to the last minute. But if you do leave it to the last minute, then obviously we have the crash course that you can try to catch up with, etc. So yeah, start properly studying 2 or 3 months before, especially because you have so many subjects to get through. This is the SL May 2025 paper. Okay, question 8. What is the retardation factor of compound X according to this paper chromatogram? What do we think? Anyone know how to calculate the RF? So the RF is going to be the distance that the pigment has traveled over the distance traveled by the solvent. Okay, so that's exactly what that is. So RF is the distance traveled by the pigment over the distance traveled by the solvent. So if this is the pigment or compound X, the distance that it has traveled from the origin is how much? So that is around 21 millimeters. So there will be RF is equal to 21 over the distance that the solvent has traveled is 21 plus the 7 millimeters there. So 21 over 28. Exactly. So that's 21 over 28. And anyone have a calculator to calculate that? I think that should be around 0.75. So that's B. Okay. Someone says wrong answer. Don't know how that is the wrong answer. I've just checked the mark scheme as well, so it's correct. But don't know, what do you mean by 23.8? Oh, they're just joking. Fair enough. Okay, yeah, so this is the correct answer. So 21 over 28. Next up, which metal has the strongest bonding? Anyone have any guesses? Which metal has the strongest bonding? What do we think? So what are the two things that metallic bonds depend on? Like the strength of the metallic bond. So number 1 is the number of delocalized electron. So always trying to consider that. And the other is the atomic radius. So it's the distance between the nucleus, which is either positively or negatively charged. Okay, so those are the two things you want to consider. Number of delocalized electrons and then the atomic radius. So if we look at our periodic table once again, let's have a look at that. We can see here our metals. Here we can see magnesium, which is right there. And we can see calcium. So which of magnesium or calcium have a higher atomic radius? It's going to be calcium. Because we know that as we go from period 1 to period 2 to period 3 to period 4, we increase the number of shells. If we increase the number of shells, that means we have a greater atomic radius. So we know that calcium has a greater atomic radius than magnesium. So if calcium has a greater atomic radius than magnesium, that means that calcium is weaker than magnesium. Why? Because if we draw it out, and this is my magnesium, which has a smaller atomic radius than calcium, which has a bigger atomic radius. I'm just going to pretend that that's a circle. If that has a bigger atomic radius, that means that if I were to bind with another molecule, the distance between that molecule's nucleus and this molecule's nucleus is so big. Okay? So that molecule's nucleus is so big. And that's why that bond is going to be weaker. Okay? If I have two molecules with small atomic radius, so for example, this molecule which has small atomic radius, and then this molecule which also has small atomic radius, they're closer together. And because they are closer together, that bond is going to be stronger. So therefore, out of calcium and magnesium, in fact, magnesium is stronger. Okay, so magnesium is stronger. There we go, because of that reason. Now, what about Sr, so strontium and barium? So strontium is here, and barium is here. Again, barium has the biggest atomic radius, and like we said, the bigger the molecule, actually the weaker the bonding, right? And the thing here, we said we also must consider the number of valence electrons, right? But the number of valence electrons, all of these is going to be 2. All of these form 2+, right? All of them form 2+. The only difference is the atomic radius. So when you solve these questions, look at the options that you have, and the options that you have, see, do they have, this is the correct answer, by the way. See, do they have all the same number of electrons, valence electrons? Do they all form, 2+, or do they form 1+? Here they all form 2+. The second thing, which one has the smallest ionic radius? Mg has small ionic radius. Therefore, that is the correct answer. Okay? Moving on to the next step. The next question. Which monomer produces this addition polymer? I'm going to ask my camera. Let me see if I can do that. Oh. Okay, it's not letting me move it, sorry. Yeah, so yes, I do private tutoring. Anyways, so which monomer produces this addition polymer? So what do we think? C, someone said C, right? No, no one said C. Maybe I'm saying C. Is C the correct answer? Okay, let's have a look. So this addition polymer. So someone asked if I can explain the last question again. Yes, I can go over it at the end of the paper. I can go through the other ones again. But okay, so addition polymers, they usually are this is a really easy tip to solve these questions, is that those long lines on either side, they're supposed to be a double bond. So we're going to find the molecule that has a double bond there on those long lines. Okay. So, yeah. So people are putting C. That is C is the correct answer. Exactly. Addition means to break the double bond and to go on. Exactly. So those extra lines here, those are supposed to be a double bond. So we are going to find the one that has a double bond there. So we have one. So first of all, let's make sure that the ones that we're looking at is the same number of carbons, right? So this has 1, 2, and 3 carbons. This one has 1, 2, 3, 4. Wrong. Automatically incorrect, right? 1, 2, 3, 4. Wrong. Automatically incorrect because it has the incorrect number of carbons. 1, 2, 3, 4. Wrong. Automatically incorrect. So this question's actually a lot easier than you think. Just make sure that you know that when there's addition polymerization, all that means is that these 2 extra lines become a double bond in the middle. That's all that is, right? So then that doesn't change the number of carbons. So therefore, the number of carbons is going to stay the same. Therefore, A, B, and D are incorrect. So the answer is C. So pretty good to get on your exam. Okay, question number 11. Which label shows the D block elements of the periodic table? So someone said B, Absolutely. So this is the May 25 SL IB exam for chemistry, time zone 2, paper 1A. Absolutely. So B is the correct answer. We know that this is not our D block. This is our S block. We know this is our P block. We know this is our D block. And we know that we don't know anything about this block and we're just going to leave it alone. So therefore, the correct answer is B. Okay, perfect. Next question. Why do group 17 elements have higher first ionization energies than group 1 elements in the same period? So why do group 17 elements have higher first ionization energies than group 1 elements in the same period? So let's have a look at our periodic table again, which is just around here. So it's saying group 17 elements, which are these ones here, let me highlight it better. These ones have a higher first ionization energy than the group 1 elements. Why do you guys think that that's true? Well, the answer is the group 17 elements are so close to having a full outer shell. They're so close to having it. Whereas group 1 is actually so close to having the full outer shell if it removes an electron. Okay? So group 17 elements, they are missing only one electron to be full. That's what that is referring to. The other thing is group 17 elements have a greater nuclear charge. They have more protons. If you have so many more protons in the nucleus, if you're fluorine, for example, and you have 9 protons versus if you're lithium and you only have 3, best believe the 9 protons are going to basically be super attracted to the valence electrons so much that they're going to pull them closer. If you only have 3, then your electron's going to be further because your 3 plus is going to be weaker than your 9 plus, right? So group 17 elements, not only are they so close to having a full outer shell, but they have more protons in their nucleus, they have greater nuclear charge. That's why it's so hard to get rid of it, to ionize it, to get rid of that valence electron. So that's why that is the correct answer, which is D. Okay, moving on. What is the oxidation state of nitrogen in N2O4? So to solve ionization state questions, what you have to do is consider that some elements always have a specific ionization state. So for example, hydrogen is always +1, oxygen is always -2. So if oxygen is -2 and you have 4 oxygens, that means that it's -8 is the charge of those oxygens. Now N2, or the nitrogen, the charge on those has to equal the charge on the oxygens. Why? Because the overall molecule is neutral. I don't have, an ion which, has an overall charge at the end. No, it's just neutral. So therefore, the charge in the nitrogen has to equal the charge in the oxygen. So I like to write it out in a little formula. I like to say 2 times nitrogen, because there's 2 nitrogens, plus 4 times my oxygens are going to be neutral. So it's going to equal 0, because that's the overall charge. Someone said the answer is D. And we know that 2 times nitrogen, which we don't know yet, because we're trying to find that state, plus 4 times -2 is equal to 0. So that should equal to -8, 2n. Divide both sides by 2. Sorry, it should equal +8, because when you switch over to the side of the equation, obviously you change the sign. So divide both sides by 2, and you're left with n is equal to +4. So the answer is indeed D. Okay, so that's the correct answer. So good job, guys. You're doing amazing. Next question. Which compound is an isomer of propanone? So what does isomer mean? Isomer basically means that it's the same molecule, just arranged differently. Okay, someone's asking about gas laws, thermodynamics. I'm sure that will come up later in the paper. Okay. So isomer is the same molecule, same structure, same elements, just arranged differently. So what can we off the bat see is definitely not the same molecule with the same structure and the same bonds? We can see B is definitely not it, because B has an OH group where this has a C double bond O group in the middle. So that's clearly not the correct one. This one also has an ester group in the middle, so therefore it's clearly not that one. This one has 1, 2, 3, 4 carbons, 1, 2, 3 here, therefore that's not that one, right? So the answer is D. Absolutely. You guys are smashing it. Okay, moving on to the next one. What is the correct interpretation of this energy profile? So here we go, thermodynamics. Perfect. So this is the amount of energy in the reactants and the amount of energy in the products. So this is what we call the delta H, and we can see that the delta H here is positive because the reactants gained energy to become product, right? So there we go. Okay, amazing. So what do we think? First of all, are the reactants more stable than the products, or are the reactants less stable? So usually the thing with the greater potential energy is the thing that is more unstable. So actually the reactants have more stability. So that is true. So A and B are true, whereas C is incorrect. It's not less stable. The less stable is the thing with the higher potential energy. Now, what is the temperature of the surroundings? So if the reactants are having more, or like they're gaining energy, or a product has more energy than the reactants, it's taking in heat, therefore the surroundings is going to get colder. So the temperature of the surroundings is actually going to decrease because it's an endothermic reaction. And if you guys can think about it in terms of endothermic and exothermic, you know that in endothermic reactions, the actual test tube gets cold, and exothermic it gets hot because it releases the heat. Here the products are absorbing the heat, and we can see because it goes up. If the graph went down, it would be exothermic. Okay, amazing. Cool, you guys are doing amazing. Next one. What is the standard enthalpy change, delta H, of combustion according to this data? So this data provides us with the amount of fuel that is burned here, the mass of the water as well. It provides with the initial temperature, the final temperature, and oh my god guys, they're being so nice to us. They've showed us the equation that we need to use, and that is Q equals MC delta T. So all we have to do really is just plug in those parameters, plug in those things. So if you have a calculator, we're going to go through it. So Q is the amount of joules. So remember, Q is in joules, that's released. Of the mass. So what is the mass of the thing that's being heated up? What is being heated up, guys? Is the fuel being heated up? Nah, it's the water being heated up. We can see there's a flame under the water. So we actually care about the mass of the water, not the mass of the fuel. So there we go. That's going to be 200 for the mass because M is for the mass. C is a specific heat capacity of water, and that's provided to us in the question. So 200 grams times specific heat capacity, which is 4.18 joules per gram per Kelvin. Great. Times the change in temperature. So the initial temperature was 21. The final temperature is 25. So we're going to do 21 minus 25, and that will give us -4. So delta T is -4. So Q is equal to 200 times 4.18 times -4. So therefore, that gives us an answer of, let's see, so 200, I've just got my little calculator here, times 4.18, hopefully you guys are solving with me, times -4. So I got an answer of -3,300 and 3344 basically joules. Now I know that to convert this to delta H, I first of all must convert it to kilojoules, and then I also need to find out how many per mole, because delta H is kilojoules per mole. This is just joules. So what I have to do is convert this to kilojoules first. So in order to do that, I have to divide by 1,000, and so that will give me -3, so I move the decimal point 3 times back, so 3.344. Then, and that's kilojoules. Then to do per mole, I have to find out how many moles of fuel, and then I divide by that moles of that fuel. So I would divide by 1,000, which I've already done. Then I would divide by the number of moles, which is 0.110. Perfect. And that should give me an answer of -30.4 kilojoules per mole. So the steps here is to, exactly, so it's B. Absolutely. You guys are smashing it. So the steps here is to, number one, calculate the amount in Q, which is in joules. Divide that by 1,000 to get to kilojoules. That's your step number 2. And your step number 3 is going to be to, divide by the number of moles of the fuel that you're trying to calculate the delta C delta H of combustion for. Okay, next step. So question 17. What is the coefficient of oxygen when the equation for the complete combustion of ethanol is balanced using the smallest whole number? So what do we think here, guys? Anyone balance equations before? So the way that you do it is you want to put carbon, hydrogen, and oxygen. So I put the elements on both sides of my equation that I'm trying to balance. So C is how many carbons do I have? I have 2 carbons here. I have 6 hydrogens, 5 plus 1. I have 3 oxygens. I have 1 carbon, 2 hydrogens, and 3 oxygens. So what am I going to do is I need to make this balance. So I can already see off the bat that on one side I have 2 carbons. On one side I have 1. So I'm going to multiply this by 2, and I'm going to make 2 carbons there. So what does that do to my oxygens? It actually makes it into 5 oxygens instead of the 3 that I had before. So in that case, I'm then going to adjust my hydrogens next. So my hydrogen here is that this is 6 and this is 2. So if I add a coefficient of 3 here, that's going to bring that up to 6. Then what I'm going to do is I'm going to see what that's done to my oxygen. Now that's made my oxygen into 6, right? Because I have 3 here, and I have 4 on, sorry, it's brought it up to 4 plus 3, which has made it into 7 oxygens actually. My pen is lagging. So yeah, that's 7 oxygens there. So then what you want to do is to adjust the number of oxygens that you have. So this is 7 instead. Perfect. Okay, so in this case, what we want to do then is we have this discrepancy. So these are balanced, these are balanced, this is not balanced. So what I can do is I know that I can add here how many oxygens. I can add a coefficient of 3 here, and that will make my oxygen 7. So then this is balanced, that is balanced, which is perfect. So this is my coefficients, 1 plus 3 plus 2 plus 3. A really common IB mistake is people won't count this 1 because they'll forget to add it. But the coefficient, the sum of the whole coefficient is 1 plus 3 plus 2 plus 3. But actually I've just read the question again, and it's the coefficient of oxygen. And the coefficient of oxygen is 3. So the answer is C. Okay, great. Next question. What are the limiting reactant and the theoretical yield of hydrogen when 0.2 moles of magnesium reacts with 0.2 moles of hydrochloric acid? Okay, so first of all, how do you find out the limiting reactant and the theoretical yield? So someone said D, so 18. Yep, so the answer is actually perfect. It's actually D, so amazing. So I'm going to go through it. So here I have 0.2 moles of magnesium. I also have 0.2 moles of hydrochloric acid. So off the bat, I can tell that my limiting reagent is going to be the hydrochloric acid because I have an excess of magnesium. So because the ratio is 1 to 2, that means that the magnesium, if I react 0.2 moles of magnesium, I would need 0.4 moles of HCl, but I don't have that, which is why the HCl is my limiting reactant. So I can immediately rule out A and B. Then it's asking for the theoretical yield of hydrogen. So this is hydrogen. The ratio of hydrogen to my magnesium, because now I'm going to, my HCl, because I'm using my limiting reactant to calculate the theoretical yield, is 2 to 1. So I have to half the number of HCl that I have. So therefore, the answer is going to be D. So perfect. You guys have got this. You got D, which is perfect. Okay. Which are the units for rate of reaction? This is a really, really, really simple question. Someone said I miss first year stuff. Yep, it gets worse. It gets worse when you add on the second year stuff for sure. So, rate of reaction is always going to be a unit of concentration. So that's going to be mole per decimeter cubed over a specific time. Okay? Now, because it's per unit of time, even though here it says second, and that technically counts. Okay, yeah, I can go back. There you go. There you go. If you wanted to copy the answers or check it out, it's fine. So, but if you want me to re-explain, let me know. So in terms of the units for rate of reaction, it has to be something per time. First of all, it has to be mole per decimeter cubed. Okay. It has to be a concentration unit per time. Now, because it's per time, the time has to be to the power of -1 when it's brought to the numerator, because when we write the rate of reaction, it's actually the same as writing mole per decimeter cubed over time, over a specific time. Now, that can be second, it can be hour, it can be minute, it can be anything really. Okay, but it has to be over time. Now, when you bring up your denominator to your numerator, okay, you have to make sure that you add a -1 to that exponent, right? So that's what you want to do. So you want to add that to the exponent. So whatever, the reason why D is incorrect, even though you might have seen D so many times in your studying, is because it's missing that -1. It has to have that -1 because we're putting it to the numerator. Therefore, we have to add that negative exponent. That's why this is incorrect. And C is correct. Okay? Yeah, the IB days. I love how this is showing up on everyone's For You page who did IB, and now they're like, oh my god, the trauma is coming back. But yeah. Okay, cool. So yeah, for this question, the limiting reagent is HCl. So because the limiting reagent is HCl, to apply the molar ratio to find your theoretical yield, you have to use the theoretical yield of the HCl. And you have to use the molar ratio of the HCl, not the magnesium, because the magnesium is excess. Okay? Oh yeah, someone's doing A-level and it's helping as well. Yes, of course, chemistry is chemistry. Nothing really changes. IB is the International Baccalaureate. This is for, I mean, I guess this is technically for the International Baccalaureate, so IB. It's not really A-levels or GCSE, but I think you would learn this in GCSE chemistry as well, because it's the SL, or standard level IB. But I think you'd also need to know it for A-levels too. Okay, so because HCl is limiting, you have to basically make sure that you use the moles of the HCl, and because you use the moles of the HCl, so 0.2, and you have to apply that to the hydrogen, because it's 2-to-1 ratio for the HCl and the hydrogen, the theoretical yield of hydrogen is going to be half of the HCl moles, which is 0.2 divided by 2, so that's why it's 0.1. So hopefully that question, that helps out. Next question, what changes increase the rate of the reaction? Okay, so anyone have any idea what the answer could be here? What would change the rate of the reaction? So, what do we think? So this is, first of all, yep, exactly, it's A, absolutely, the right answer is A, but let's talk about it. So catalyst definitely increase the rate of reaction. That's literally in the definition of a catalyst, right? So absolutely, because a catalyst speeds up the rate of reaction by providing an alternative pathway, absolutely. If you increase the concentration, you have more, yeah, you are passing, absolutely. If you increase the concentration, you have more particles, and if you have more particles bumping into each other, this is a standard level paper, by the way. If you have more particles bumping into each other, according to collision theory, what this means is that you're going to have a faster rate. Absolutely. So that's why I and II are correct, or 1 and 2 are correct. Now, statement 3 says increasing pressure. And I would argue that if you had gases, increasing pressure actually does give you more concentration per unit, so per unit of area. So that does increase it, but only in gases, guys. Only in gases. If you see a question and it's asking about increase in pressure and rate of reaction in something that has aqueous and liquids, that is not going to, yes, I can zoom out, that is not going to increase the rate of reaction. So we're only looking at increasing pressure affecting the rate of reaction only in gases. So keep that in mind. If it was gases, if the reactants were gases, absolutely. If the reactants are not gases, then I would consider, then I would say that this is incorrect. So the correct answer is A, which you guys got anyway. So you guys are smashing it, doing amazing. Someone asked, do you still offer crash courses for chemistry? Yes, absolutely. You can get them on our website, and they basically cover the whole syllabus, and we go through practice questions, etc. Do I do tutoring? Yes, I do, and it's on the website. It's in the link in bio. My name is Minna, and you'll find me on the website, basically, and you can book sessions there. You can also purchase the crash course, and that basically has live teaching of all the topics of the whole syllabus from start to end, including lots of different practice questions as well. And the November one is not live. It's actually a recording of the live sessions from the May exams. So you can literally purchase it anytime and watch the recordings at any time. And it's broken up by topic. This is not OCR, but it's just chemistry. So chemistry is chemistry. It'll be useful for if you use any, like, it'll be useful for any of your, any of your chemistry courses, whether that is A-level, GCSE, whatever. It'll be useful. Okay. Oh, thank you so much, Paul. That's really sweet of you to say. Okay, so how much is the crash course? The crash course, honestly, I think if you're HL, the most expensive is the HL package, the full package, and that's, I think, £100. But it's a lot cheaper if you're SL. I think, I'm not sure of the exact price. It's on the website, but yeah, go have a look. But yeah, it covers the whole syllabus. It's actually probably the cheapest thing you can get on the market right now. Definitely cheaper than some of the other IB products out there. Okay. Why does rate of reaction increase with temperature? So someone said, is the answer A? So the answer is not A, but I'll give you another chance. So why does it increase with temperature? And that's basically, when we look at rates of reaction increasing or decreasing, we have to think of collision theory. Collision theory says the more amounts of collision, the greater the amount of successful collisions. So if you increase temperature, you're not changing the way that the particles are moving, but what you are is increasing the kinetic energy. So when you add temperature to anything, when you add heat to anything, yes, absolutely, the answer is B. Absolutely, perfect. You guys are smashing it, honestly. So when you add heat to anything, you're adding a specific energy, okay? Because, like, there's a law in physics, and it basically says that energy can never, just leave. So if you're adding heat, that energy gets converted to a different type of energy, and that is kinetic energy. So when you have greater kinetic energy in the particles, which is aka movement energy, you increase the amount of energy in the particles, and therefore a greater proportion of the particles in your mixture are going to meet the minimum activation energy requirement to get the reaction. So that's B. So temperature affects it in two ways: energy requirement, and also affects it in making the collisions more collisions, because the particles are just moving faster, they can bump each other more. Someone here is doing physics. Yeah, IB physics is great, but so is chemistry. The following system is at equilibrium. What is the value of the equilibrium constant K for the reverse reaction? So the reverse reaction is not 2SO2 plus O2 goes to SO3. It's the opposite. So it's SO3 going to 2SO2 O2. Now, I would recommend that you guys write it out in reverse so you do not mess this up, because we know that the rate constant is products over reactants, right? So we want to write it out again. So 2SO3 goes to 2SO2 plus O2, just so we don't get confused, right? Just so we don't get confused. We know that it's products over the reactants, right? So it's going to be equal to these products over this reactant. So K for the forward reaction, basically the fact, like this top one here is 4.3. Therefore, for the reverse reaction, it's going to be the opposite of that. Okay? I'm so sorry. I'm so sorry to hear about your exams not going great, but you can always try again. Always try again. Yes, absolutely. Chemistry and physics do go hand in hand. But yeah, if it's the reverse reaction, it's going to be the opposite. So instead of doing products over reactants, it's going to be reactants over products. So it's just going to be exactly the opposite. So we're looking at reversing the denominator and the numerator. And so what we're going to do is just reverse it. So instead of it being 4.3, we're going to reverse it to 1 over 4.3, because they give us the K already for this one. So therefore, the answer is C. Okay, just because we're literally switching what is product and what is reactant. Okay. What is the effect of doubling the pressure on the equilibrium? All other conditions remain unchanged. Now, so SO2 plus O2 goes to SO3. So what do you guys think the answer is? Someone said C. Okay, where do we think the equilibrium shifts if you increase the pressure? Okay, so if you increase the pressure, what you want to think about is the fact that with gases, I want you to see in your head, whenever you increase the pressure, you're actually increasing the amount of moles of gas. That's all you're doing. Okay? That's all you're doing when you increase the pressure. So how many moles of gas do I have on this side? I have 2 and 1, right? So that's 3 moles of gas on this side. Here I have 2. So if I increase the pressure, I'm favoring the side with more moles of gas. So I've actually favored this side. So what does the equilibrium like to do when you favor one side? It likes to do the exact opposite, because remember, that's Le Chatelier's principle. So therefore, the equilibrium is going to shift to my product side, which is the right side. So therefore, we're going to remove B, because that's not correct. We didn't say it shifts left, we said it shifts right. And what about my equilibrium constant? Is it going to increase, or is it going to have no change? My equilibrium constant, no change. The only thing that changes the equilibrium constant, guys, always in any paper, in any exam, is only temperature. That is the only thing. If they ask you about anything else changing it, pressure, concentration, catalyst, it does not change the equilibrium constant. Therefore, C is also incorrect, and the correct answer is A. Okay. Yes. What is required to convert a base into its conjugate acid? So what do we think? Question 24. So someone guessed B. Good guess, actually. Really good guess. Okay, people are putting D, absolutely. So B and D are really similar, because actually a hydrogen atom technically does have a proton, it's just one proton, but it's not a positively charged. I think maybe if you were thinking of H+, and yes, if that's the case, that would be correct. But hydrogen atom, remember, is just H, not H+. That's why the correct answer is D, which is actually H+. Absolutely, great. So the answer is D. So you can convert a base into its conjugate acid by basically taking away, making it be a proton donor. Yeah, absolutely. Making it be making it become a proton donor, so therefore giving it a proton so it can become a proton donor. Okay? Amazing. What solution has a pH of 9? Okay, have a guess at this one. What day are you doing the lives? My next one is going to be on Tuesday. So I'll be going live on Tuesday as well for bio. And then I'll do another chemistry one on the Friday, I think, of this week. Okay. Which solution has a pH of 9? So we have A, we have B, we have D as well. Okay. So I can reveal the correct answer is D. So the way that you guys can work this out is being able to basically calculate pH this is chemistry, by the way, is so super duper easy. So what you want to do is use the equation where the pH is equal to, anyone know the equation, by the way? Negative log base 10 of the hydrogen ion concentration. Remember that you can rearrange this, absolutely, into the hydrogen ion concentration is equal to 10 to the negative pH. So here I'm given the concentration. And so what I can do is just take that number at the top, and that's my pH. That's literally what that is. So my pH for NH3 is technically 9. However, I want you guys to think about what this is. This is a base. Okay? So if this is a base, the concentration, this is an acid. So the concentration of this is actually not a pH of 9, okay? Because it's actually just NH3 plus, which means this is my H plus. Now, what about NaOH? NaOH, the 9 here refers to the concentration of the OH. It's the POH. So because of that being the POH, what's going to be true is that this 9 is my POH. So therefore, my pH is going to be equal to what? My pH is going to be 14 minus 9, which is equal to 5. So B actually is a pH of 5. Now, what about this one? NH3 plus. Okay? NH3. So NH3, those two solutions will not have a pH of 9 because it doesn't make sense for it to have a pH of 9. It's a base, right? So it's definitely not going to have a pH of 9. Now what about this one? NaOH. NaOH, again, because there's an OH, we're actually with the 5 finding the POH. So POH is equal to 5, and we know that POH plus pH is equal to 14. Therefore, the pH is going to be equal to 9. So the answer here is D. Okay? So that's what we're looking at here for this question. Okay? Obviously, you can feel free to calculate the pHs using this with your calculators. Absolutely. If you have the time, do this in your exam if you want to be absolutely sure. Just remember that sometimes with these concentrations, you're actually finding the POH and not the pH, which actually it's really mean for the IB to put a question like this in the SL paper, because technically knowledge of POH and pH is not really needed for the SL syllabus. They haven't put it on their syllabus like outline. They've said it was an HL thing, and then they stick it on the SL paper. So I'm not even surprised. Literally not even surprised. They do this all the time. Yep, exactly. It's a yes. So I think you're thinking of NH 4 plus. I think that's what you're thinking of. If you're thinking of this being an acid, that's an acid. NH3 is the base. Okay, moving on to the next question. What is the main reason why sulfuric acid has a lower pH than methanoic acid of the same concentration? So why does sulfuric acid has a lower pH than methanoic acid? Why do you guys think? So yes, I do offer private tutoring that's on the website that you guys can sign up to. Absolutely. So sulfuric acid we know is a strong acid. We also know that methanoic acid is a weak acid. So weak acids basically are less likely to dissociate in water. So because they're less likely to dissociate in water, they're actually they're not going to give off that proton, that H+, and we know that the ability of acids to give off that proton or dissociate is how strong they are. So methanoic acid is a weak acid. It doesn't dissociate, so the H+ actually doesn't leave the methanoic acid molecule. It stays in that molecule. It doesn't leave it. That's the whole definition of a weak acid. Strong acids, they dissociate a lot in water, so they give off H+, H+, H+. They give it off so much. H+, 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 H+. Okay? So the H+ is going everywhere, and it ionizes so easily. Okay, so that's why the correct answer is B, because ionizing more just means dissociating more. Okay? Let's look at the other options. Sulfuric acid is more soluble in water. That's not really true. It's not that it's soluble, it's that it dissociates more. It's a stronger conjugate base. That has nothing to do with why it has a lower pH. Sulfuric acid is diprotic, whereas methanoic acid is monoprotic. Again, that's not the reason why. Okay? In which compound does sulfur have an oxidation state of +4? So here, to calculate the oxidation states, if you guys remember the formula I taught you, remember that hydrogen is always +1. So let's look at the oxidation state here. If we have 2 times +1 for the hydrogen, that means that this will be +2 and the sulfur will be -2 to make sure that the whole molecule is neutral. So sulfur here is -2, so it's not +4. What about this SO3? So for this one, the oxygen is going to be -6. The sulfur is therefore going to be +6 to cancel that out. So that will be sulfur of +6 oxidation state. What about H2SO3, guys? So H2SO3, here we have -6 from the oxygens. So this is redox. So this is the redox topic of chemistry for IB. This paper is SL May 2025 exam. It's a leaked paper from that previous exam session, and it is standard level. Okay, so the oxygens create a -6 charge. The hydrogens are each +1, so that's +2, and therefore the sulfur is +4 here. Okay, if you guys want me to go through it more thoroughly, step by step, let me know. And then here it's -8 for the oxygens because each of them, so yeah, absolutely the answer is C. And then here, this is +2, so the sulfur is +6 there. So that's why that's incorrect. Okay, amazing. So next step, magnesium displaces silver from the aqueous silver nitrite. So what is the correct description of the sulfur electrode in the cell shown below? So what is the sign on the silver? So is it positive or negative? And therefore is the electrode the cathode or the anode? I'm a student technically. I'm actually a university student. I'm not a high school teacher. I don't teach high school, but I do teach the crash course, and I am a private tutor as well. Okay. So magnesium displaces silver from the silver nitrate. So what does that mean, guys? It means that the magnesium is basically like more reactive than the silver. That's what that means. Because if you can displace something, if you can displace another molecule, another metal, it means you are more reactive. So magnesium is more reactive. So if magnesium is more reactive, that means that magnesium is better at being a metal. So if magnesium is better at being a metal, what do metals like to do? What do you guys think? Do metals like to become Mg+, or do they like to gain electrons? They like to lose electrons, right? If they're metals. Yeah? So magnesium likes to lose electrons. So therefore, magnesium is more likely to become magnesium 2+, and that is going to be more likely to get oxidized, because metals love to get oxidized. And if you are the more reactive metal, you are the one that's going to dissociate more. Yes, this is the same at all chemistry. Chemistry is the same everywhere, guys. So this will be useful for anyone who's doing chemistry. Okay, so magnesium is more reactive. It's better at being a metal. Therefore, it's going to be the one that oxidizes into Mg2+. Okay? So that's what's happening there. So if magnesium is more likely to get oxidized, that means your magnesium metal is losing electrons and, letting off electrons here, 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 and here. So this one is my anode. This is my negative electrode, because magnesium here is losing so much electrons. Absolutely, magnesium is a strong oxidizing agent. So if this is my negative electrode, did not mean to erase that. That's my negative electrode. This has to be my positive electrode, because my silver, even though it's also a metal, it's weaker. It's being displaced. It's so weak. So therefore, that's why it's going to do what metals hate to do. What do metals hate to do? Is gain electrons. Therefore, silver is going to gain electrons. And as it gains electrons, that means it's going to be my positive anode, because that's the one that electrons are going to be attracted to. Okay, so anodes are the ones, yes, so my teacher would answer in a different way, so I'm kind of confused. Oh, yeah, don't worry. It's hard to understand. Absolutely, it is hard to understand. So I can re-explain it again if that makes sense. Basically, the first statement here, magnesium displaces silver from aqueous silver nitrate, that tells you which one is more reactive. So if magnesium can displace silver, it can push silver out, and if it can push silver out from the silver nitrates, that means it is more reactive. Absolutely, absolutely. If magnesium is more reactive, that means it's better at being a metal. So if it's better at being a metal, that means that this is the one that's going to lose its valence electrons. Okay? So it's going to be the one that is losing the electrons, so therefore this is going to be my negative electrode. Because if I'm losing electrons, getting rid of electrons everywhere, all the electrons are going to be surrounding that anode. Electron, 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 electron. This is negative. Okay? Hopefully that makes sense. Then look at our silver. Our silver is less reactive. Because it's less reactive, what's going to happen? Is that it's doing what metals don't want to do. What do metals hate to do? Metals hate to gain electrons. They're like, bro, I only have 2 valence electrons. Please get rid of them. But here we are going to force that metal to gain electrons. Okay? And if it's gaining electrons, that means the electrons are attracted to it, which means it has to be a positive value. Okay? Redox is such a hard topic, guys, honestly. So I wouldn't worry if this is super confusing. You have loads of time before your exams. If you are studying for November, maybe you're a little bit cooked if this is still not making sense, but please just reach out and I'm sure any of the team can help you. Yes, so the crash course of the 5 days of learning the syllabus is already over. Today we're just doing past paper review. The 5 days crash course is already on the website and it's already been done. You guys can watch it whenever you want, really. Okay, is this for GCSE? Yes, so GCSE does teach this as well. Metals do not all have the same charge, depends. Some of them have +1, +2, +3, but they all like to be positive. Anyways, so the sign on this electrode is going to be my positive sign. So we can exclude C and D if you've been following along. And if this is the one, so if this is the one that's positive, it's the one that's gaining electrons, it's the one that's getting reduced. Therefore, reduction always happens at my cathode. So that's why A is the correct one. Okay? Which change represents oxidation of the functional groups? So there's 3 different ways you can think about oxidations. Either loss of electrons. You might have heard the mnemonic oil rig. So oxidation is loss, reduction is gain. That's to do with electrons. Someone asked me, if this is going to gain electrons, why is it positive? It's because for the electron to be attracted to it, it has to be positive. Right? So the electron has to be attracted to it. That's why. Okay? Because electrons are negative. Okay? Anyways, so oil rig. And reduction is gain. Again, that's in terms of electrons. Now, you can also think about oxidation as gaining of hydrogens, gaining of oxygens or loss of hydrogen. So you can also think of oxidation as loss of hydrogen or gain of oxygen. So in this case, the best one to look at this of definition to answer this question is the loss of hydrogen aspect. And here we can see that this is a carboxylic acid, and this is organic chemistry, by the way. So carboxylic acid, and it becomes a ketone. So this actually is not oxidation, this is a reduction, because actually we're losing an oxygen. You see that? We've lost an oxygen. That has to be reduction. Now H2CO becoming HCOOH. So in fact this is oxidation because we're gaining an oxygen, right? So remember, you can think about it as loss of hydrogen or gain of oxygen. Okay? Oxidation is absolutely loss of electrons. So oxidation is loss of electrons, absolutely. You can also have loss of hydrogen as oxidation. You can also have gain of oxygen as oxidation as well. Okay? Yeah, absolutely. So oxidation is loss of electrons, but gain of oxygen, loss of hydrogen. Okay? This one, there's no oxygens being passed around. It's not oxidation. Also, it would be oxidation if I was losing hydrogens, but in fact I'm gaining hydrogen, so C is incorrect. H2CO to CH3OH. Here I am gaining hydrogens, really, because I'm having 3 hydrogens, so it would be reduction, not oxidation. Letter A, yes, this is an aldehyde. Sorry, it's not a ketone. Ketone's in the middle of the molecule. Aldehyde's at the end, so absolutely you're correct. Okay, hopefully that makes sense. And now we're on to the last question of the paper, guys. Lock in, because this is the last question. Which equation represents propagation in a radical substitution mechanism? So remember that radical substitution has 3 steps. It has initiation, which is the creation of the free radicals. So that's where the free radicals are created. This is organic chemistry, by the way. Propagation, which you create, so the free radicals end up creating more free radicals. So you keep creating more and more and more, a cycle of more and more and more free radicals. So you need to start with a free radical and end with a free radical. And termination, where you start with a free radical and you end with not a free radical. So the free radical is gone. Okay? So that's that. So we need to find a step which starts with a free radical and also ends with a free radical. So which one is that, guys? What do you think? So this one has a free radical starting and ending as well. Perfect, that's a correct one. This one starts with free radicals, but it ends with a not free radical. This has to be a termination step, not a propagation step. So it's not B. This one creates 2 free radicals. That must be an initiation step, not a propagation step. Now this one starts with a free radical and also ends with a free radical. However, this hydrogen free radical is not a real step. So if you guys actually went through the steps and studied them, those ones, that's not a real free radical that would make even more free radicals. So therefore this D is incorrect. So the only free radicals in this process are going to be your free radicals that have to do with chlorine, so your Cl free radical, and your methyl group free radical as well. That could be a valid one. Or if you had fluorine, again, it would be a good one as well. So free radical is a molecule that has 1 unpaired electrons. Yes, absolutely. I love that you guys are helping each other in the comment section as well. So that's it. That's for the whole paper. If anyone has any questions on any of the questions we went through together, feel free to let me know. Also, please give us a follow so you can stay in touch and know when we're going live next. If you want to do even more chemistry or biology revision, I'm going to be going live again on Tuesday this week at like 7:30. Of course, I'm glad that it was helpful. I'm going to be going again live Tuesday this week at 7:30 for the biology students. No, we do long answer questions as well. So in fact, I have another paper. I don't know if you guys can see this, the paper 1B, which I was actually gonna go through in another live. So here we're gonna go through like longer answer questions. I just thought to do multiple choice first. But yeah, make sure you follow us so that you can get the so you can get up to date with all the lives. Yes, I got the IB papers from IB Documents, absolutely. But yeah, I'm so glad you guys joined me today. If anyone has any questions on like revising, on IB, revision, I actually did the IB myself a few years ago and I graduated. It's just an international baccalaureate, so it's like kind of like A-levels or GCSE, but for like high school for international students. Usually it's like it can be taught in international schools or just normal schools as well. I'm glad you found it helpful. But yeah, I just found them from IB Docs. Yeah, the long answer questions are not the best, but I feel like sometimes they're really repetitive, so they're actually quite good. Because you can get specific marks because they repeat themselves a lot. I feel like the multiple choice questions, they're more creative with them, so that has more room for error. If you practice a lot, I think paper 2 gets easier and paper 1 gets harder. Where can we find these papers? These are on ibdocuments.com. So if you I would go on Reddit and find the IB Docs repository. I'm so glad I helped you as well. But yeah, you can find them on Reddit, you can find them on IB Documents. There's like a repository with so many past papers, all the M25 papers. They've all been leaked, I think, from all the subjects. So not only from chemistry and bio, you can find them from all of them. And yeah, they're up there. Good luck to you guys if you're studying for November exams. And join along next time. We're going to be going through the paper 1B from this paper. So these are the longer answer questions. We're also going to do paper 2 as well. So yeah, join us next time. I'm going live again for bio on Tuesday at 7:30 UK time. And then I'm also going to be going live for chemistry again on the Friday. But yeah, any questions, let me know. If anyone wanted to go through any of the paper 1 sections again, let me know. But thanks for joining along. Give us a follow if you want to join us for more lives. And if you want us to go through more of these live sessions. And yeah, thank you guys. Enjoy your evenings. I'm probably going to end the live soon if no one has any more questions, actually. The redox reaction. Yeah, I can go through that again. Okay, so would it be this one? Or the other, like the calculating oxidation state ones? I think it's this one that the person was asking for. So basically, for this one, it's really simple. Yeah, I can go back to the last question again, don't worry. But I'll go through this one first. So basically, for this one, it's really, really simple. So what you want to think about is what the information is given to you from the paper. So the paper says magnesium displaces silver from silver nitrate. So that basically tells me that magnesium is more reactive than the silver. Because when we want to find... it's after this one, sorry. Wait, you mean like to go through another question after this one, or this question and then another question after that? Sorry, I'm just a bit confused. Or did you want to go through a different question to this one? So not this one at all. Oh, this and the other ones. Okay, fine, no worries. So if magnesium displaces silver, that means magnesium is more reactive. Hopefully you guys are up to track with that, the fact that magnesium is the more reactive one. If magnesium is more reactive, then that's the one that's going to get oxidized, because metals love getting oxidized. So metals heart oxidation, honestly, because oxidation means that they get to lose their electrons, and we know that for example, metals like magnesium, because they have 2 valence electrons in their outer shell, they want to lose those electrons. So metals love oxidation because they have a small amount of electrons in their outer shell. So if metals heart oxidation, we know that the stronger metal is going to be the one acting like a metal, and the weaker metal is going to be the one that's going to be getting reduced. Okay, so if magnesium displaces silver, that means magnesium is more reactive, therefore it's a better metal, so therefore it's going to be oxidized. So if it gets oxidized, that means that magnesium is going to become magnesium 2+, and it's going to shed all of the electrons. So all of the electrons are going to be, moved away from magnesium, and it's all going to go into the solution. Basically, it's not going to go into the solution. It's going to be magnesium 2+ is going to go into the solution. So basically, the magnesium is getting rid of a bunch of electrons. If the magnesium is getting rid of a bunch of electrons, then this is my negative one, right? Because if you guys can imagine, this is solid magnesium. This is pure solid magnesium. And if I want to become oxidized, aka lose my electrons, my magnesium 2+ goes into the solution while the electrons stay behind. Electron, 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 electron. Okay, does that make sense? So this is my negative electrode, basically. Does that make sense? So if this is my negative electrode, and it's where oxidation takes place, this is going to be my anode, where oxidation takes place. So what about my silver? My silver is going to be my positive electrode, because you always have to have one negative and one positive, right? So this is going to be my cathode, and this is where reduction is going to take place. Does that make sense, guys? Hopefully. So that's why the answer here would be positive sign for the positive electrode, right? Because silver is going to be reduced. And it's going to be the cathode, because the cathode is always where reduction takes place, and the anode is always where oxidation takes place. So hopefully that makes sense on why this would be the correct answer, and why not the others. So it's really, really simple. Don't try to think about it too much, because I think when you think about it too much, it will get so confusing. But it's, again, just go back to basics. Metals, heart oxidation. The stronger metal is going to be oxidized, therefore that's going to be your anode, because oxidation always happens in the anode, and we know that in a voltaic cell the anode is negative. We can also just think about it of exactly what's happening in the electrode. If it's getting oxidized, getting rid of so many electrons, the electrons are all there, it's going to make it negative. Do you know the Caribbean Secondary Examination curriculum? I actually am not familiar with that, but if you let me know the topics that would be covered, I'm happy to go through the questions that are on this paper that belong to that topic. Chemistry is chemistry all the way throughout the world, so they're going to have similar questions for all these examination curriculums. Electrolysis. Yeah, so electrolysis would be very similar to voltaic cells. In this paper, I don't think there's electrolysis because that would be a higher level content for the IB students. So when we do the higher level paper, you can join along and we can go through electrolysis as well for that reason. Someone asked for another question though. Someone asked me for the last question of this paper. So that's this one here. So propagation and radical substitution. So there's 3 steps of radical substitution. There's always initiation, propagation, and termination. Initiation is where you create a free radical. So you start with a non-radical and you end up with a free radical. And then with propagation, you start with a free radical and you end up with another free radical. With termination, you start with a free radical and you end up with not a free radical. So to answer this question, and it's asking us for a propagation step, we had to literally just find the step that would start with a free radical and end with a free radical. And in this case, that was A, because that little circle here that you guys can see on the chlorine, that's what means free radical. Okay, that's what shows that this is a free radical. So therefore, free radical ending with another free radical, that would be an accurate propagation step. Now, you actually physically, it's impossible for you to have a hydrogen free radical because the hydrogen already has an unpaired electron. That's just H+, basically. It's not actually a hydrogen free radical because hydrogen can't have a paired electron in the first place. It can't have 2 electrons in the first place, so you can never have a hydrogen free radical, which is why D is incorrect, even though it looks like you have start with a free radical and end with a free radical. And this is where the IB really distinguishes between students that have crammed last minute and people who tries to confuse you basically. Because of it shows you something that's impossible, and you would know it's impossible if you practiced a lot, and if you didn't practice a lot you might fall for the trap basically. Okay, so that is the last question. Someone asked me another question: do you have a balancing of redox reactions? I unfortunately do not have that for today, but we do cover that in the crash course if you want to go over that for redox reactions. And it goes through the step by step. Hopefully in another paper it has that question. When we go through these past paper sessions, we can go through that as well. if you guys want to request like a redox session just on redox, because I feel like that's such a hard topic, please just DM us, please just let us know, like email us, etc. Give us some sort of feedback, and that will let us know like what sessions you guys are looking forward to. All of our contact details are on our website, so all you have to do is just go on our website, which is, the link is in the bio as well. Okay, someone asked for other questions after this one, which I honestly can't remember, but I think it might have been the oxidation state one and the balancing one, right? I think. Let me know if I'm wrong. So to find the oxidation state of something, so I'm going to go through a few examples here. So for H2SO3, what you want to do basically is so H2SO3, the rule is hydrogen always has an oxidation state of +1, and oxygen always has an oxidation state of -2. And another rule that you guys have to obey is that basically this molecule, if it doesn't have a charge on it, what I mean by that, if it's not like this, for example, which is NH4, and I write plus, if it doesn't have a plus charge, that means that that has a neutral charge. So therefore, the charges have to be equal to 0. So the charge of 2 hydrogen molecules, and I write 2 hydrogen because there's 2 hydrogens, like it's H2, plus 1 sulfur, plus 3 times oxygen molecules, that has to equal to 0 because the overall charge on the molecule is 0. Okay, so 2 times hydrogens is going to be 2 times +1, because remember the rule is hydrogen is always +1, plus sulfur, and sulfur is going to be our mystery one. We're trying to find out what oxidation state sulfur is, plus 3 times the oxygen, which is always -2. Again, that's one of our rules that we have to obey, and that should equal to 0. So 2, because 2 times +1 is 2, plus sulfur, plus -6 has to equal to 0. So therefore sulfur -4 is equal to 0. So therefore sulfur is equal to, or the oxidation state of sulfur is equal to S equals to +4. And so that's why the answer here would be H2SO4, because that has an oxidation state of +4. So that's how you would solve for oxidation states. So there is a -2 on top. It means it's equal to -2. Yes, absolutely, absolutely. So let's say you had, for example, like OH minus, and you were trying to find the oxidation state of something, then that your overall charges have to equal to -1, not equal to 0. Another thing is, for example, like SO4 2 minus, because that one has 2 minus, exactly like you mentioned. Let's say I'm trying to find out the oxidation state for sulfur in SO4 2 minus. Remember, rule number 1 is that hydrogen is always +1 and oxygen is always -2. So therefore, the sulfur plus the 4 times oxygen, right? So I'm going to write oxygen so it's not confused with 0, should be equal to -2. Sorry, I know that's a bit cut off there, but sulfur plus 4 times my oxygen should be equal to -2. So therefore, sulfur plus 4 times my -2 for each of my oxygens should be equal to -2. So sulfur -8 should be equal to -2, so therefore sulfur here is equal to +6. Okay, so that's what that is. That's finding the oxidation states for something that has a charge on it. Remember that the value that you equal to at the end, the charges all have to add up to the charge on the molecule. That's literally what that means. Okay, so that's how you would solve for these compounds. Someone's asking about half reactions. Yeah, so unfortunately there isn't a half reaction question here. Usually they come up in paper 2. So stay tuned for the paper 2 session, which will be on, I think it'll be Friday this week. I'm not sure if it might be earlier, but yeah, if it is earlier, I'll let you know. And yeah, so that is how you would solve that. Is there one with rate of reactivity? Yeah, there was a few ones on this paper actually for rate of reaction. So that would be here. So what changes can increase the rate of the reaction? And basically here you had to identify that, introducing a catalyst would increase your rate of reaction. Increasing the concentration of your reactant would also increase your rate of reaction. And that increasing pressure would increase it. However, that only happens in gases. And here your reactant is not a gas. It's an aqueous solution. So 3 would be incorrect and A would be the correct answer. Did you do the IB exams? Yes, I did do that. I did do the IB exam a few years ago. I thought it was math. I'm not associating with chem. Yeah, this is so much math, honestly. Yes, I did do the IB exams a few years ago. In Belgium, I did my DP2 as well. I did higher level chemistry, higher level bio as well, and I got I think 41 points overall for my diploma. But now I do IB tutoring, and yeah, I'm currently a student at university. But yeah, what about you guys? Okay. I'm probably gonna end the live soon because we've now gone through all the questions and we've repeated the questions that people wanted to go over again. I think if anyone doesn't have any other questions, I'm going to probably end the live, and I will see you guys on my next live, which is going to be on Tuesday this week. Do you have videos on YouTube? Yes, we do have some videos on YouTube. I mistakenly did chemistry. Oh my god, don't worry. Honestly, chemistry is not that bad, but you just have to really understand the content and have a good teacher. If you have a bad teacher, chemistry is awful because nothing will make sense. I'm studying at Imperial College in London at the moment. What's the YouTube? YouTube is at Easy7. At Easy7 IB Scientist, I think, or just at Easy7. It's on our website. Like if you scroll down, you can just click for the YouTube logo, and that should bring you to our YouTube channel. We have a few past paper sessions on there as well. How often should I study chem? I'd say like once a week if you're far away from your exams, but I would say study like maybe if it's closer to your exams like 3 or 4 times a week. I would say like once a week, and then if you have a test coming up, do like 2 or 3 times a week. Oh my god, no. Are you guys studying for November exams? Is that why? But yeah, I can definitely do more lives. So can you send me questions on balancing redox reactions, those ion transfer method? So that one, honestly, for those questions, I would say like do a lot of past papers, and then you'll be able to find past papers on IB documents. We do have questions. We do have practice questions on them. However, they're part of the crash course, so I don't think I'll be able to share those with you off the bat. But we are coming out with a new we are coming out with a new question bank, which will have those, but that is coming out in the next few months. But anyways, yeah, that's part of the crash course. Feel free to, purchase that, and you can have access to like loads of practice questions of every single topic. But at the moment, what I would say, if you're looking for those specific questions, either like go on IB documents, and there'll be loads of textbooks that are like pirated for free. There's also loads of like past papers, and just do those. Do you do CSEC anytime in the next week? Sorry, I'm not sure what CSEC is. Is that like a specific curriculum? But yeah, honestly, chemistry is chemistry. So if you find any of those questions, so I'm gonna try to do those lives. Oh, fine. So no, I'm not doing specific Caribbean secondary examination curriculum. It's more for the IB diploma. But feel free to join. Honestly, the content is going to be really, really similar. And if you go through your curriculum and see where there's overlap with the IB curriculum, you'll be able to like join in on our sessions as well. Feel free to. I do these lives I try to do it like once a week, if not 2 times a week. We have another tutor as well who does these lives as well. So hopefully we can try to keep up with the once to twice a week. But we are trying to build like a whole new platform for IB students as well, for like question banks and stuff. So that's taking up so much time. But yeah, please stay tuned and follow us for more lives. Because we just love to help students, really. Oh, the dipole moment. Yeah, that's fine. We can go through that. Okay. So this one honestly is a bit tricky, and basically in order for something to be polar, there has to be like a difference in electronegativity that's different between the 2 molecules. So for example, like if you look in your data booklet and you find the electronegativity value for carbon, that will be something like what, like 2.1 or something like that. And then for oxygen, I think it's like 1.2 or something like that. It's in the electronegativity data booklet table, so you guys can find that directly there. These are not the exact numbers. I don't know the exact numbers because I don't have it off the top of my head, but it will be something like that. So just for examples purposes, this is what you would see. Then if you subtract 2.1 minus 1.2, that will be equal to 0.9. So therefore, because it falls within the range of 0.4 to 1.7, of electronegativity difference, that means that the bond itself is polar. So for something to be polar, it has to first have a polar actual bond, which in this case, both of these bonds are polar. And in fact, these bonds are polar towards the oxygen, because the oxygen is more electronegative. I don't know why I said it was 1.2 here. It would probably be the opposite, where the oxygen is 2.1 and the carbon is probably like 1.2 or something like that. But the oxygen is more electronegative. So what that means is the oxygen loves electrons more. So if the oxygen loves electrons more, it's going to carry the electrons closer to it. Okay? So even though they're sharing it in a covalent bond, the electrons are actually carried closer to the oxygen. That's literally what that means. And so they're sharing electrons, but it's unequal sharing. That's literally what polarity means. So each of those bonds are polar. So that already fulfills that one scenario. Now for the second scenario, this depends on the shape of the molecule. So some molecules are linear, in which, like, I don't know if you remember Vesper theory or like how the shape of the molecules are, but linear basically just means that they're like shaped like a line, right? And here the carbon dioxide bond and molecules is linear, so they're shaped like a line. So if I were to draw the dipoles for each of those bonds, the way that you draw dipoles for polar bonds is that you do the plus sign for the molecule around the sign that's less electronegative, that has a delta positive charge, and a delta negative around the oxygen, because that has a partial negative charge, because it has more electrons around it, and you draw that line like this, where the arrow points towards the negative, and like that. Okay, because you have two of those bonds. Now the key is, if your arrows are tail to tail or head to head, that means that they cancel each other out. Because if you look at your overall molecule, like, you're going to have negativity here, you're going to have negativity here, and both sides of the molecule are negative, therefore the molecule overall is not polar. For a molecule to be polar, one side has to be positive and one side has to be negative. But because the arrows are both pointing outwards, both of these sides are negative, therefore the molecule is not polar. Because polarity means unequal sharing of electrons. Okay? And a molecule that's one-sided in a side that's positive and a side that's negative, which is not the case here. Okay? That's why this molecule is non-polar, because dipoles cancel each other out. I was trying to check which crash course to buy for my chemistry. I have something written HLSL. So yeah, higher level is for students that are taking the higher level IB chemistry course. Standard level is for students taking the standard level course. If you click for more information on those courses, you'll see the exact topics that is included within that course. Do you sometimes help with the chemistry IA? Yes, I absolutely do. I have a few IA students at the moment, and we're going through the whole process for the IA, from, coming up with a research question, writing it up. I'll tell you exactly what to write, how to get the maximum marks for each point of the rubric. And you basically just buy like a package, and that package basically includes 2 hours of me giving you live, like, explaining what to do, and live commenting on your paper and your IA, and then on top of that you'll get unlimited feedback, like, offline. So if you share Google Docs with me, I'll be able to comment and improve your IA as much as possible. I just do physical science at high school, which has physics and chemistry. Which one to buy then? Oh, I see. In that case, could you please DM us your curriculum, and we'll let you know which parts of the curriculum align more, like, with what course. What grade are you in? Usually if you're in high school, you probably will cover all the content of the full syllabus. How do I join or pay for the package? The package is just on our website. So if you go on our website, it has like a button that says IA guidance, or if you go under private tutoring as well, you can just, get that there. If you can't, honestly, we have a little like chatbot that all of us get access to. So if you can type in the chatbot exactly what you're looking for, and the same for person with ZM. If you type in that chat box on our website, we get all of those messages and we're able to give you a response. If you just let us know what your syllabus is, what exact kind of help you're looking for, we're more than happy to help you. And yeah, for the IA package as well, just DM there. We'll find you a tutor. We'll match you up. Probably it will be me. And we can go through the IA together. What if we deal with a molecule that is not linear? So if the molecule is not linear, in the case that it is for SO2, because the molecule is bent like this, then what ends up happening is that I will actually draw a nonlinear molecule now. So SO2 is nonlinear, so it looks like this. Okay. So the bonds is like that, right? Instead of it being linear like this. So, oh, someone's preparing for the IMAT. Best of luck. I'm actually a medical student myself, so I had to do like the BMAT. But yeah, best of luck for the IMAT, honestly. This is related to hybridization? No, not really. Kind of, but not really. Not really related to hybridization. Hybridization is something in higher level that we do, which we will cover when we do like an HL past paper. Not that much hybridization, but it is like bonding, which is under the hybridization, under the bonding topic as well. So I can see where the thing is. Okay, so back to the point. What if the molecule is bent or nonlinear? If the molecule is bent or nonlinear, that means that if you draw the molecule, and if you were to draw your dipoles themselves, your dipoles would look like this, where this is the negative side, and this is the more positive side, because the oxygen is more electronegative, like this, and this is the more electropositive, sulfur. And if you were to look at my molecule, the another thing that you can do is something called the dotted line test, which I didn't go through in the main session, because I just thought, too much detail, I'm trying to go through it in the most efficient way. But another test that you can do is something called the dotted line test. So the dotted line test is if you can draw a dotted line across the molecule, and one side is negative and one side is positive, that means that you have a polar molecule. Okay? So if you can draw a dotted line, whether that's vertical or horizontal across your molecule, if I were to draw it like this, both sides are basically negative. So that's not polar. But because I can draw it the other way horizontal, where one side is positive and one side is negative, that means that molecule is polar. Because the whole thing about polarity is part of your molecule has to be partially positive and part of it has to be partially negative. The other thing is, if I relate that back to the dipoles, is that these dipoles are not canceling each other out. They're not tail to tail or head to head. They're actually both pointing diagonally down. Okay, if they're both pointing in that same direction diagonally down, that means that contributes to an overall dipole moment that is overall downwards. So overall, I have a side that's positive and a side that's negative. That's the key thing with polarity, is that a molecule has to have polar charges, polar bonds, but it also has to have asymmetry. So where one side is positive of the molecule, the other side is negative. Yes, you are supposed to know the shape of SO2, because when you cover topic 4, you're supposed to be able to draw out the molecules as well. Because when you go through VSEPR theory, you go through, how to draw these molecules, these Lewis structures, and then you'll get to know which molecules are bent, which of them are linear, which are tetrahedral, which have all these different other shapes. Okay? So yeah. Okay, hopefully that made sense. Yeah, so I'm going live for bio next Tuesday, 7:30. I think someone was asking as well about how do I purchase only chem and not bio. So you can absolutely just, purchase chemistry. The crash courses are separate. So you can buy chemistry or you can buy biology. They're completely separate. Again, just please message us. We're on the website. We're happy to send you the link, of exactly what to go and everything. But yeah, why is CO2 linear? And SO2 is bending. They have similar bond, but why SO2 is bending? Really good question. It's because SO2 has a lone pair here. That's why. So I didn't draw the lone pair on, but it has a lone pair. And remember, according to VSEPR theory, when you add a lone pair, it causes bending of the other molecules. Does that make sense? So yeah, chemistry only and not biology. You can get that off our website. You can also get biology off our website as well. We have past paper sessions, we have all the different types of sessions. We have a crash course, covers everything from the IB syllabus. Yeah, chem is great. Someone said, am I the only one in MYP? Oh my god. Potentially you're the only one in MYP, but yeah. But yeah, I think, to be fair, I'm not sure how much they cover of chemistry in MYP. Do they cover a lot in MYP in chemistry? Yes, absolutely. The lone pair give repulsion to the other bonds so they are bent. Exactly. You can't see the option on choosing chem here. Okay, you know what? Don't worry. Have you been able to see the little chat button on the side, please send us a message. I literally get the notification like right now if you send a message on our website, and I'll be able to follow up with you. I can let you know like exactly what to buy. AP Chem is sometimes harder, yes, because AP Chem would include the higher level content. So if you come to our high level lives, you'll see it takes another step. It gets a lot harder, which is why AP is at the same level as basically higher level chemistry rather than SL chemistry. Your teacher teaches about POH and pH and SL. Honestly, good for her. I taught it as well in the crash course because I just thought, you know what, IB always does this, where they always say it's SL content, but they, HL content, but they put it in SL. But yeah. Yes, I do lives from time to time. My next one's going to be on Tuesday at 7:30 UK time. And because of that, because I've covered chemistry today, I'm going to be covering biology next time. But yeah, if you guys do have any other questions or you want to reach out to us, please go on our website and like text the little chat button on the side, and we'll be able to like answer all your queries. We can take our time and stuff. But yeah. It's just on our website, link is in the bio, and we can help you out with all of your queries. But yeah, I think I'm going to end this live now, because I've been yapping for so long, and we've gone through the whole M25 SL chemistry paper. Our next time for chem is going to be probably on the Friday. We are probably going to do physics as well, because we have a tutor that can teach physics as well. So we're going to try to get her to teach physics and do a past paper for that as well. So follow along and you'll be able to do some of those lives. We're also looking at potentially doing math as well for, paper 1, paper 2 walkthroughs. So yes, goodbye everyone. I'm going to end the live, and yeah, please follow along to keep up to date with our lives. Our next one is going to be, of course, you're welcome, guys. It's going to be on Tuesday, 7:30 for biology. We're going to be going through specifically content that's really difficult from the syllabus. So we're going to be going through, the muscle topic and, cell respiration, and we're going to be through all that from bio. So, yeah, follow along, and I will see you guys on Tuesday. I'm going to end the live now. Bye! Okay. Let's see. Bye. Thank you. Have a good day as well.